Hello friends, in this lecture we will do some examples based on the deterministic finite automata. So first example is construct the minimal DFA that accept all string of zeros and ones including epsilon. What is the question? Construct the minimal DFA for the language that contain all strings of zeros and ones including epsilon. Clear? Listen carefully. First we will discuss what do you mean by the minimal DFA. Listen. For every regular language we can construct so many DFAs, but minimal DFA is unique. We can construct for a same language different DFA, but minimal DFA is unique. What do you mean by the minimal DFA? That contain only minimum number of states. Then first we will write what is the language. What is the input alphabet? Input alphabet is 0 and 1. What is the language? It includes epsilon, 0, 1, 0, 0, 1, 1, any combination of 0 and 1. Any combination of zeros and ones. Clear? Then how we will construct the DFA, minimal DFA for this language? First we construct the skeleton. This is the initial state Q0. When epsilon is present in the language, then initial state is final state. Listen, I repeat, when epsilon is present in the language, then initial state is also final state. If it is final, then we will represent by the double circle. What is the definition of DFA? Each and every state have exactly one transition on every input symbol. In this state have one transition for 0 and one transition for 1. So we can write this 0 either 1, any combination of 0 and 1. This is the minimal DFA for this language. Clear? You can check. It accept 0, yes, 1, yes, 0, 0, yes, 0, 0, 1, 1, yes, 1, 1, 0, 1, yes, first time is 0, second time it considers as a 1. Clear? So this is the minimal DFA for this language. Clear? Check. If you have any doubt, you can ask me. This term is very important. Minimal DFA. First we write the language, after that we create the skeleton, then creating the skeleton, after that we make that skeleton as a DFA. Next question. Next question. construct the minimal DFA that accept all string of A's and B's where each string start with A. Clear? You can draw. Take some time and draw this DFA. See, what are the input symbol? A, comma B. What is the language? What is the minimum string that accept this DFA? Only A, AB, ABB, AA, ABA, and many more. Each string start with A. Now, construct the skeleton. This is the initial state Q0. When we read input A on this state, it goes into the next state, that is Q1, and this one is final state, because this language contain only A. When we read a string A and it goes into the final state, this is our skeleton. Now, make this skeleton as a DFA. What is a DFA? Each and every state have exactly one transition on every input symbol. Each and every state have exactly one transition on every input symbol. We have two input, then each state have two transitions, one for A, one for B. Now, Q0 have transition on A, yes, but Q0 does not have any transition on B. Then make a transition B. If I make the transition B here, it means it start BA, it start with B, it accept BA. That is not my language, so we cannot make this transition. Can we give this transition B? No, because it accept single B. Single B is not present in my language. We cannot give this transition and this transition. Then what will happen? If we come on to this state, it goes to the data state. Data state, some books also called trap state. Now make this state as a data state and gives the transition A or B, because to satisfy the DFA definition, each and every state have exactly one transition on every input symbol. Q have two transition, one for A and one for B. Clear? Now check this state Q1. Q1 does not have, right now does not have any transition on input symbol A or input symbol B. Can we make this transition? Yes, because AB in our language, ABB in our language, AAA in our language, every string constructed by this DFA is accepted by the DFA. So this is the DFA for given language. Check. Have you any query? Clear? Okay. Now move to the next question. move to the next question. Question number 3. Construct the minimal DFA that accept all string of A's and B's where each string end with A. Each string end with A. End with A. Clear? Now what is the input symbol? A and B. What are the language? Each string end with A. Only A is accepted by this DFA? Yes. BA is accepted by this language? Yes. BBA? Yes. Double A? Yes. Sorry. Yes, this is also accepted by because it ends with A. BA? Yes, and many more. What is the minimum string? Minimum string is A. Now construct the skeleton for A. Construct the skeleton for A. This is the initial state. A is accepted. A is accepted. Now, make this diagram as a DFA. What is the transition of B? This one. Why? Because BA is also accepted. BBA is also accepted. Triple B is also accepted. Q0 have two transitions, one for A, one for B. It means this state is satisfy the definition of the DFA. Now come to the Q1. End with A. End with A. End with A. A is accepted. Yes or no? B double A is accepted. Now, what is the transition for input symbol B onto the state Q1? A, B, A is accepted or not? A, B, A is accepted. A, B, A is accepted. This is the minimal DFA for this language. Clear? Are you getting my point? Clear hai? Any doubt? Remember one thing, whenever epsilon come into the language, then initial state is final state. Rather than other state also a final, but initial must be a final if epsilon is present into the language. Next question. Construct the minimal DFA that accept all string of A's and B's where each string start with AB. Each string start with AB. Example number 4. Construct minimal DFA that accept all strings of A's and B's where each string start with AB. Clear? Construct. Done? Okay, we'll check. What are the input symbols? A and B. What is the language? Each string start with AB. Minimum string is AB. Now A, B, A, and many more. Start with AB. Start it with AB. So first construct the skeleton for this string. Q0. Read a input symbol A, goes into the next state. Read a input symbol B, goes into the final state, Q2. This is our skeleton. Now make this as a DFA. Make this skeleton as a DFA. Can we give transition B on this? No. Then what will happen? Whenever B, input symbol B, come onto the Q0, it goes into the dead state. Machine goes into the dead state. One DFA have only one dead state. Now check this. Can we make A as a loop? No, because if we give a loop A onto the Q1, it accepts A, B. But this is not present in my language. That's why the transition of A onto the Q1 goes onto the dead state. Now come to the Q2. Transition A and B, because after that AB we can have any number of A's and B's, So this is the DFA for the given language. Check. Please check. Any doubt? Any doubt? Next question. Construct the minimal DFA that accept all string of A's and B's where each string start with A and end with B. Construct the minimal DFA that accept all strings of A's and B's where each string start with A and end with B. Clear? Clear? Very good. Now what is the input symbol? A and B. Write down the language. What is the language for this given question? Each string start with A and end with B. The minimum string that is present in language is AB, double AB, ABB, ABAB. Now construct the skeleton for this language. The minimum length string is AB. Length of the string is 2. Construct the skeleton for this string. After that, make as a DFA. Yes. Q0 is the initial state. Read A goes into the next state Q1. B goes into the final state. This is our skeleton. Make as a DFA. B, if B is come onto the Q0, it goes into the dead state. Clear? If A come onto the state Q0, it make as a self loop because AAB present in this language. Clear? Now B, because A double B triple P present in this language. Whenever A come onto the Q0, it goes into the Q1 because A, B is accepted by this finite automata. This string is present in our language. What is the language? Start with A and end with B. Start with A and end with B. Clear? Now check. This is the DFA. Each and every state have exactly one transition on every input symbol. Clear? Good. Next question. Construct the minimal DFA. Construct the minimal DFA that accept all strings of A's and B's where each string contain AB as a substring. AB as a substring. Clear? Now make the DFA for this language. Make the DFA for this language. Make the DFA for this language. What are the input symbols for this language? A and B. What is the language? AB as a substring means first string is AB, A double B, double A AB, B AB, and many more. Which one is minimum? This one is minimum. This one is minimum. Now, Construct the skeleton for this string. Construct the skeleton for this string. Do fast. This is the initial state, Q naught, A, Q on Q1, B, it goes into the final state. This is our skeleton. Now make as a DFA. Yes, we can give the loop for this state because we have this string in our language. Now A, because A, B is also present in our language. A, comma B. Clear? A, B. This string also present in our language. So this is the minimal DFA for the given language. Clear? Now check. Have you any doubt? Have you any doubt? No. Next question. Construct the minimal DFA that accept all string of A's and B's where the length of the string exactly 2. Construct the minimal DFA that accept all string of A's and B's where the length of the each string exactly 2. Exactly 2. Construct the minimal DFA that accept all strings of A's and B's where length of the each string where length of the each string exactly 2. Clear? Input symbol A and B. What is the language? Double A, double B, AB and BA. This is the finite language. In this language we have only four strings. Clear? Length 1, length 2. Here we can put A or B. This is the state, initial state, and this one is the final state. Clear? Each state have exactly one transition on every input symbol. Q not have A or B transition. Q1 have A and B transition. But Q2 does not have any transition on input symbol A and B. If A and B come onto this state, it goes into the dead state. This is our DFA for this language. Clear? Next question in this category. Construct the minimal DFA that accept all strings of A's and B's where the length of the each string is at most 2 at most 2. Make DFA for this language. Clear? What is the input symbol for this? A comma B. What is the language? At most 2 means epsilon is also accepted. Single A is accepted, B is accepted, double A is accepted, double B is accepted, AB is accepted, BA is also accepted. This is our language. This is finite language. If epsilon is come onto the language, then make initial as a final state. This is the Q0. This is also final. When we read A, it is also accepted. When we read B, it is also accepted. When we read AA, this is also accepted. When we read AB, BB, this is also accepted. Make this diagram as a DFA. Q0 have one transition for A, one transition for B. Q1 have one transition for A, Q1 have one transition for B. But Q2 does not have any transition on input symbols. If A and B come this state, then it goes into the dead state. Suppose we have a string AAB. This is not present in my language because the length of the string is 3. But my question is at most 2. Then A is come. When we read a Q, when we read a on Q0, it goes into the Q1. When we read again A, it goes into the Q2. If we read B on Q2, it goes into the dead state. This string is not accepted by our DFA. Clear? Check. Clear? Next question in this category is at least 2. Question number 9. Construct the minimal DFA that accept all strings of A's and B's where length of the each string At least 2. At least 2. Clear? Now what is the language? Double A, double B, AB, BA, AAB, BAA and many more. At least 2. At least 2. At least 2. Q0. At least 2. First we make for DFA exactly 2. After that, any number of A's and B's are come. This is DFA for length of the string is at least 2. At least 2. Clear? Check. Check these 3 questions. Check these 3 questions. And analyze these 3 questions. What are the pattern in these questions? Okay. Now, next. Question number 10. Construct the minimal DFA that accept all strings of A's and B's where the length of the string first exactly 3, second at most 3, at least 3. Make the DFA for these 3 languages. Do fast. Have you done it? Okay. First one. Exactly 3. The length of the string exactly 3. We can put A or B, A or B, A or B. Q0, this is the initial state. Q1, Q2, Q3. This is our final state. If A and B come onto the Q3, it goes into the data state. This is our first question. Now, second, at most 2. At most 2. Sorry, at most 3. It means initial is final. This is length 0, length 1, length 2, length 3. Clear? This is for at most 3. If A and B comes onto the state Q3, it goes into the dead state. Clear? Next, third one. At least 3. Q0, length 1, length 2, length 3, at least 3, any number of A's and B's. Clear? Now analyze the general way for this type of questions. See, note, length of a string irrespective to any number of input alphabets. Number of states in minimal DFA. First is length of the string exactly n mod w, where w is the string. Length of the string exactly n. Then number of states. See this picture. In case of exactly 3, number of states 1, 2, 3, 4, 5. 3 plus 2. 3 plus 2. The number of states n plus 2. N plus 2. In case of at most, number of states is 5, means 3 plus 2. Second, at most n. At most n. Length of the string is at most n, less than equal to n. It means at most n. Number of states n plus 2. In case of at least 3 plus 1, 4, n plus 1. At least 3. At least 3. At least 3. Number of states n plus 1. Clear? Clear? Remember these 3 points. Okay.